All right.
Well, this is the June 15th, 2021 session of Tangerine SDR and HamSci technical sessions. My name is Dave, KV0S, and this week I've been working with both Nathaniel and Kung, and with Bill and Tom and Scotty. And so we've been trying to make some progress on where we're going, trying to get all on the same page. And that's about it for me. Next on the list is Nathaniel, the W2NAF. Go ahead, Nathaniel.
Thanks, Dave. I've just been continuing to work with students here in dev at Scranton, and next week is a CDR workshop, so I'm getting ready for that. W2NAF, back to net.
Well, fine business. And next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Okay, thanks, Dave. Yeah, well, I've been working on trying to get the specification for the protocol between the data engine and the local host finalized, and I found out that my documentation that I have on it so far leaves much to be desired. But we're going to get that worked out in the next few days. There's two different documents that are both out of date and they don't really agree with each other. So, but anyway, Tom can report on this. Tom McDermott can report on this here in a few minutes. He's got a first version of his software which talks to the simulator. I sent him some code, some Python code, because my specification was wrong. And so anyway, we'll get there. We'll get there. Also working with Nathaniel a little bit on trying to finalize how to handle the magnetometer data. I had a misunderstanding on how we were going to save that data, but there's multiple ways to do it. But it looks like we're going to use maybe Dave Witten's technique, storing as CSV, but we're going to just, in the production version, at least for phase one, store it on the UA server. So playing around with that a little bit. So anyway, making progress. Back to net.
Well, fine business. And next on the list is Dev, KC3PVE. Go ahead, Dev.
Very good evening to everyone in the community. So we have started our new week here at the University of Scranton. We had a group meeting in the morning and we discussed how we would be presenting in CDR workshop. We discussed our research progress by each of the members. And there are junior members also joining the group. Our high school senior has joined the group. So I think these are exciting times and a good beginning for the summer, I would say. Thank you.
Very good. And next on the list, we have Chong. Go ahead. Chong,
You mean Kung?
I'm sorry, Kung. Sorry. Kung, are you there?
I am here. Can you hear me?
Okay, go ahead.
Oh, hello everyone. So this week I've been working on the project with the TangerineSDR FPJ with Dave and Scotty. So this week I continue trying to communicate to the NEOS2 processor. Well, at first I thought it worked because so originally I couldn't find the NEOS2 terminal command, but then when I switched to using the Linux machine, command was there, so I thought it worked. But then when I actually run it, I actually found out that it gave me an error saying that the JTAG, there's no JTAG device available, which doesn't make sense because I already have the board plugged in through the UART cable to the Linux machine, and then I run JTAG config command, which is, I think that's the one that Scotty was talking about before, that will show me which address is the USB blaster connected to. And when I run that, it's actually said there was no JTAG device connected, which confused me even more. So I'm stuck there with that. And then I tried to look into the RAM test, as Scotty said. I found some C code for those RAM tests. So I think I know what I have to do. Then I think I just have to convert those codes from C into Verilog. I think that should be doable. I mean, after I finished working, like figuring out how to communicate to the NEOS 2 processor. So that's it for me. Thank you. Back to you.
Well, very good. Sounds like you are making some progress. It takes a while to figure out each of these steps.
Thank you.
So very good. And next on the list, we have Dave, KD0EAG. Go ahead.
Hello. Hello. I don't know exactly what I've been doing, but I guess I've been working today on my more, hopefully more usable substitute for the RunMag program for gathering data, one that has configuration files and all manner of things that make it a little more civilized. I don't know whether that's going to be very important to this project, but I'm working on it all the same, trying to figure out what I was thinking when last I looked at the code and where I put where things went. I was refactoring stuff a lot, I guess. And, things are in different files than I would have guessed, but that's most of my excitement for now, I believe. Over to you.
Okay, fine business. And next on the list, we have David, W1HAC. Go ahead, David.
Well, that would be N1HAC, but
Oh,
close
sorry.
enough. That wouldn't go through the bureau, but yeah, good evening, everyone. Let's see, a number of things. One, we just finished up a student just finished up who was working on our AM Doppler project. Hoping to put a paper out so as people can see what she's been doing. She has done a senior thesis on it. Very good work, correlating what we've been seeing to TEC GPS data and transient ionospheric disturbances. And we're going to be building out that system. I've been asked to put together a few more of the R receivers. Looking forward to the point where we can put out tangerines instead of these type of machines. We're also working on our Baffin Island receivers. Likewise, love to run tangerines up there, but we're going to be running a different SDR. And let's see, two aside. One is there's 6 meter activity going on right now. 6 meters has been pretty crazy. And then, on the magnetometer, I just got a shielded 100-foot cable, which I haven't had up till now. Though I myself haven't had a whole lot of trouble with interference from the mag. I'm hoping to do some more near field testing for interference and what shielding I feel will be necessary for that. But I think, as we were discussing last week, much of that noise is coming from the Pi and whatever else will be attached to it, rather than the magnetometer itself. And one last thing on the mag, I'm wondering if there's any chance of working on a real-time display for the magnetometer, because I'd love to be able to watch it rather than just collect data. Back to net.
Fine business. Dave, do you have a comment?
I was just saying, thinking a real-time display has been something I've played with off and on, and I start on something like that, and then I start to feel I'm stepping on other people's toes, or they have plans to do all that sort of thing, so I stop spending time on it and go back and forth. I've kind of that's one of the reasons I'm trying to differentiate the software I'm writing from anything else related to this project, because it's very, very hard to keep communication, even knowing what anyone else is talking about, let alone what they plan or making progress with. But that's it's not that hard to make a real-time display of it, and I'd be happy to.
Dave, did you have an idea for something that just displays the numbers or something graphical? Because I've got a real-time thing that updates in real time that runs now using the magnetometer data. You connect to the local host and do magnetometer calibration, and it shows you the XYZ data, and it updates every 1 second. And you can, the way I use it is I go out in my yard and I connect to the local host on my smartphone and using the web interface, and I can view what the different axes are showing as an aid to taking the magnetometer and rotating it into the right place. But I guess you might be talking about something graphical that shows ongoing
plot of
Yeah,
the data.
well, what I'm talking about is something graphical, not just numbers. Your eye can't follow the numbers. And something that ideally you could change the amount of time displayed, so that you could say, what has it done in the last hour or the last day or the last week, that sort of thing.
I have worked on a little bit on all of the above, but mostly I've thought in terms of something graphical. They're usually something through a web, something that presents a web page that could be easily displayed. I've looked at plotting, various plotting functions. I've looked at even, well, more in the line of what Bill, you're talking about. I was working on one kind of like that using OpenGL or WebGL, but that probably is a lot of work for not so much return right now. All
of that extra toilet. But no.
But Nathaniel's talked about wanting to see what real-time updates in plotting, I believe, several times, and I kind of go that way. It's not impossible. I could work on that if somebody says to make it a priority. It might not fit in with the rest of what you're doing as the main, it'd be hard to make it, to coordinate with you. I don't want to get in the way of you're doing what you're doing. It might not be a drop in to the existing stuff, but the data is there, and it's not that hard to update a plot,
Well,
Yeah.
at this point, I don't think you'd be stepping on anybody's toes if we can get even a rudimentary display that we can use.
I can try to do that. I really want to make
Thanks.
some progress on this other reading program too, because I put it aside when suddenly other things came back to life that I had thought were dead. So I'll try to do that and try to stick to tools that other people might find useful. I'm tempted, I keep tempted to do what I know the best, but that may not be what fits in well. My natural inclination is to use some Node.js stuff, but and that's not part of this project, and probably for good reasons. But it could be a useful tool in the meantime. So I'll see about that.
Thank you.
Okay, next on the list, we have David, KE8QEP. Go ahead, David.
Hello, I think I've maybe been here once before, but I'm new and I'm a new ham. But I did through another ham get my grape, and I just got the first two ICs. on that today, actually, well, just a few minutes ago. But actually, I'm really interested in the magnetometer data, and especially seeing how local influences and things like trucks going by. I've got a probably typically sized suburban lot, so I would really like to get one of these magnetometer boards if they're available. In fact, I ordered the magnetometer chip yesterday. Maybe I was a little too excited, and maybe the board's not really available, but I'm really interested in playing around with that, or just seeing what kind of data it produces. I've used some magnetic data in the past related to animal tracking and navigation at a very simplistic level, but I'm really excited about the magnetometer, and maybe I should ask that out of the Zoom. I don't want to take time up here, but I find it interesting. Back to Ned.
Well, very good. And I think Nathaniel we're still working on prototypes right now, and I don't know how many we have. You don't have any more available, Nathaniel?
We're really low on them. We only have like 2 left, and I think we want to hold on to those for now. So I don't know if there's I don't know if it's reasonable to do something like what we're doing with the grape, where people can make them if they want to, but I don't know.
Well, I'll talk about that in a little bit in the free session, Nathaniel. I got some input for getting this off the ground so we can get tappers selling them.
Yes.
So
that would be good.
I have one extra board, so I'll take a look. I'll see what I can do. If David, if you want one set.
Yeah, I have an extra board here that I could contribute to that.
Very good. Well, let's go on down the list, and let me see. Everything's jumping around. Hillman is the next person on the list. So where did you go? K2M
Good evening, everyone. This is Julian. Yeah, I've been working on this documentation very slowly. Not so much of progress this week. I've been restricted many other stuff, but it's coming along. I'm very excited to see people very interested in magnetometer work. There has been really interesting conversation, email thread among us. That's exciting. It's always fun. The only thing that I want to say is that some folks are concerned about like noise. Of course, noise is a very big issue. But as long as the noise source, although it's hard to specify the noise source, as long as the noise source is not consistent, constant, some kind of intermittent noise source may be okay. Especially like if you're in a rural area where there's no big disturbance, but if you have some kind of maybe some big tractor coming by for a very short period of time, that doesn't really ruin data acquisition that much, because what we're looking at is like half an hour to several hours of event. So say a couple of minutes of tractor passing by, that doesn't really impact the data quality that much. Of course, any constant noise, yeah, that's something that we should really avoid. So that's all. Back to Nat.
Very good. And next on the list is James KG4DSG. Go ahead, James.
Good evening, all. Not much to report here. I did post a link in the chat that Michelle Thompson, which I think some of you may know, was interviewed on a podcast in the last week, talking about the Open Research Institute. One of the interesting things she did mention is they have set up what they're calling open labs for FPGA development. Not a lot of details on it in the podcast, but I'm going to be looking into that in the future. With that, back to the net.
Well, fine business. And next on the list is J, WB8 SBI. Go ahead, Jay.
Yeah, good evening, everybody out there. Nothing really new from this end. Just a comment on Michelle Thompson in the 2019 AMSAT annual meeting and Space Symposium and annual meeting. I sat with her next to her or near her, and we had dinner as part of a group dinner, sat next to her there, had a very enlightening conversation with her. She's really a nice person and very technically competent. So if you ever get a chance to say howdy to her, I urge you to take that opportunity. Otherwise, not a whole heck of a lot here. So 7-3 to all and back to net control.
Okay, and next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, Dave, and everyone else here on the net. Been monitoring WWV, and there's some pretty sharp disturbances in the last several evenings, and also working with Steve on time of flight, trying to get a calibration point to measure the signal from WWV, and it's somewhere around 3.2 to 3.6 milliseconds from here in Flagstaff, and I'm about 525 miles from Fort Collins. So that's what I've been up to. Go ahead, Dave.
Well, fine business. And next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I've been working on my active VLF antenna test box. I did a electrical check of my active VLF antenna, and I was able to get an audio signal. So it is definitely working. I was going over the design in my head with the test boxes. Going to do when I finalized it, ordered parts. I found out that the DC to DC converter that I'm using, the input voltage spec is 9 to 36 volts. And if you feed in 8.7 volts loaded from a 9-volt battery, you'll only get around 1 volt on the output. So those even just a couple hundred millivolts, and the DC to DC converter doesn't work at all. What I'm going to do for my test box is I'm going to use 2 9-volt batteries to power the DC to DC converter in there, and that'll output 36 volts to feed down the line to the DC to DC converter in the active VLF antenna. And I actually got the parts today. Also, I was fighting with my new college, graduate school. They have decided not to transfer 2 of my courses. So that's a long undertaking to get that fixed. Other than that, I don't have anything else. Back to the net.
Well, fine business. And next on the list is Jules K2KGJ. Go ahead, Jules.
Okay, good evening to everybody. Regarding noise from the magnetometer, I have a multiband trap dipole within about 80 feet of one of the magnetometers, and I've never noticed any noise from the magnetometer itself, but I do get a few spurs from the pi. Actually, the pi is located in with the rig downstairs, and my Cat5 cabling comes into that area, but they're small. Actually, I get a substantially more interference from our washing machine than I do from the pi. The washing machine, in fact, tends to blank out 20 meters when it's running. Anyway, not much other progress, Hyman, on what I promised you I was going to try to do this week on checking the construction stuff, but I'm going to work on that next week. Most of this week I spent on a physics experiment associated with what's called the Wheeler-Feynman absorber theory and the transactional interpretation of the Copenhagen interpretation of quantum mechanics. Anyway, with that, back to net, and everybody looks good. So let's hope for a good week. Go ahead.
Fine business, and sounds interesting. Next on the list, we have Con, KE8QWB. Go ahead, Con.
Hello all. Yeah, after the solar eclipse event, the data collection, I found out what I needed to do. So I redid my rig. I'm redoing my rig right now, my SDR rig, to minimize noise and any kind of interference. So I've been working on that. But since you guys were talking about like graphical user interfaces, yeah, where anything to do with like, you know, native WebGL or OpenGL, anything GL, like that thing is very tedious. So my recommendation is to use like some higher level libraries, because that's what I'm, but right now I'm programming OpenGL on with MGUI, dear MGUI UI to do some data collection stuff too, and that's pretty tedious. And I used to do WebGL, but I kind of like put it down on the back burner because I heard there's some limitations, and there's going to be a new thing coming out called WebGPU, which would cover those limitations, but it's still in the beta phase and it's not stable yet. So yeah, so right now I'm just doing just OpenGL stuff. But yeah, it's very tedious. So, yeah, that's pretty much it for now. Back to net.
Well, fine business. And then we have John, KJ6IBP. John, go ahead.
Not much to say. I'm glad I can make it to this conference.
Fine business. Looks like it's still sunny there.
Oh, it is. It'll be sunny for a few more hours. It's 6:30-ish p.m.
So next on the list, we have Michael, AA8K. Go ahead, Michael.
Oh, thank you, Dave. Greetings to everyone listening. Had something interesting going on towards the end of eclipse monitoring. On this desktop, this particular hard drive, solid state drive, decided to misbehave. And so that took out the end of my 5 megahertz WWV. No, that was a 10, come think of it, sorry. So I reloaded put in a new SSD. By the way, this one was not even 2 years old.
Oh, wow.
2 years use. And my other drive on the desktop is spinning magnetics, and it's been running for 4 years.
Yeah.
It's happy. So that meant I put in a new solid state drive, and I put in the latest Ubuntu long-term support. And I tried to start recording this session and discovered that I can't record it.
Oh.
For some reason, I can see the audio in Pulse Audio, but the 3 recorders I tried want to use also.
So
I have to resolve that. I'll grab the recording from Nathaniel's recording. Back to you, Dave.
Fine business. And I'm going to go ahead and pick up Veronica, KD2UHN. Go ahead, Veronica.
Hi, how are you? Lately I have been working on my CDR poster quite a bit. And then aside from that, I've been going to the Thursday telecons again. And then I've been participating in the Rock On workshop. So I've been going to some Zooms for that. I just recently finished up building my payload and found out it got accepted to fly on the rocket ship. So I'm really excited.
Oh, great.
And then other than that, thank you. And then other than that, I've been working with another student. She sent me some of her code. She's been doing a similar thing with the kind of tracking the direction of TIDs. And so I've just kind of been looking through that to gain an understanding of the method she's been using and how we could apply that to what we're trying to do. So thank you, back.
Very good. And I want to
that would be the same student that David McGaw just talked about.
Okay, very good. And I want to pick up Will K2KGJ. Go ahead, Will.
Yeah, hi. I'm sorry I don't have much to add on the magnetometer other than I've been to every site between Fairbanks, Alaska and the Yukon River crossing deploying MIT's Mahaly systems, but I'll just introduce myself. It's Will Rogers. My call is KD4FOV. I work for Phil Erickson N1PJE, which you guys might be familiar with at MIT. First time on this Zoom call. Very interesting. So hello, everybody.
Hello, Will. And next on the list, let's go to Scotty. KD0, no, WD0.
What about WA2DFI?
There you go.
I faked you
Go
out
ahead.
by using my commercial Zoom account ID here. So
Well, and you also jumped around on me.
okay, well, thanks, Dave. This week we've just been trying to do cleanup on the 3 documents. We got the I just got the plots today. We got the clock module, the new oscillator subbed for the old oscillator. We got that cleaned up, and got all of the length matching done on the data engine, and just have a few things left to do on that. And then there'd be some changes to the radio board. Hold on, it's a train crossing. Got a few mods on the radio board that we have to make. Phone is insistent, you know.
That's like being close to a temple, okay?
That's right. Actually, ironically, I have train tracks that run right behind the house here, and it sounds a lot like, it used to sound a lot like that, but all right, that's it. I'm going to put it in a box and fill it with water in a second. Anyway, we have tracks right behind the house, and the neighbors don't like the train horn, so they all got together, and now we've got a silent zone, and they don't blow their horn anymore, which is really, I like the horn blowing, but you know, apparently I'm in the minority, so I don't get to hear the train horn anymore.
Are you an HO modeler?
No, in the old days, yeah, but not anymore. But it's just cool to have the train. I mean, it literally runs right back behind my rear gate by about 50 feet. We actually have a right of way of the Southern Pacific Railroad with borders on our lot here. So, and you heard of all the shortages of wood and oil and all the things. Well, we've been seeing a whole lot more trains going through here. It's not passenger trains we see. We see cargo trains, and they're all heading westbound, almost all of them, and they are all wood. Yes. 2x4s, plywood, car after car after car, just stacked with wood, and in between them is tanker cars. So I mean, I'm guessing it's oil and lumber is what's going to the West Coast. And actually, for the first time yesterday, I saw one going eastbound, loaded with lumber, but almost all of them are going westbound toward California. So anyway, back to what we finished up. Almost done with the boards. I think by the end of this week, we're going to be done with all the layouts, and we're going to be ready for some reviews. And I talked to Nathaniel a little bit about this. I think we want to try and have some peer reviews and scheduled on Zoom where we go through the designs and just show everybody, you know, you're welcome. Even if you're not a board designer, you're welcome to join in, because like I always said, is that the questions that the non-designers ask are going to show up any mistakes that I've made in designing these boards, and Tom on the RF board and John on the clock module. So more people that look at it, they're going to find the obvious things, or maybe not so obvious, and they're going to ask about them. We're going to go, oh yeah, that's not right, and we'll fix it. And let's see what else. Yeah, I shipped out Nathaniel. I shipped out Ward's magnetometer, and so now we're down to not just 2 left. And in the free time here after the free for all, I want to talk to Dave and Jules about the new magnetometer changes that I think I got them all, but I've got a proposed layout for the board, and I want to show it to them and have them say, you idiot, you didn't account for this, or it's okay, and it'll fit in with the mechanical build it in the pipe system that you guys have been working on. So I guess that's about it. Back over to you, Dave.
Well, fine business. I don't know at all. And next and final is Tom McDermott, N5EG. Go ahead, Tom.
Oh, thanks, Dave. It's been a busy week. Bill's been a great help. I got his DE SIM code compiled for x86 and running on a VM on the server. I've got the Python module read and write code talking to the DE SIM, and that read and write code's on a different virtual machine. That's written in Python. It's object-oriented Python, so it can handle multiple different data engines at the same time. And that comes up and negotiates the config channel. Bill, I thought more about the bytes for the module read and write, and I'm going to put out an email to you, Dave, and Scotty with some clarification. Scotty, when I was looking at SPI, I found out that there are some 8-bit and some 16-bit data SPIs. There are some 256 register and some more register SPIs. There's some SPIs that use rising edge clocks, and some that use falling edge clocks. And so I propose to add a target register on the module write that will tell the FPGA how to actually write to the interface, what clock edge, how many data bits, and all of that kind of stuff. So the FPGA won't need to know all that kind of stuff, that the module write will be able to inform the FPGA what kind of a write it needs to do. So let me document my thoughts there, and I'll circulate it to everybody and we'll collect it. I thought single bytes were going to be adequate. And then the receiver has more than 256 registers on the ADC. So whoops, that one went out the window. So at any rate, I'll put something together and have it. At any rate, we're making good progress, and having the data engine simulator is extremely valuable. It's already caught a whole ton of things. So good job, Bill, on that. Thank you. That's it.
Well, I think that's everybody on the list has had a chance. So we'll be open for general discussion.
I want to add something I forgot to mention regarding the eclipse in our AM Doppler project. At first, I was thinking that we weren't going to be able to see much because the eclipse happens during the day. And then I realized, wait a minute, it delays sunrise. And, to us who were in the Northeast, we were actually able to see the eclipse, and it rises at essentially at maximum. So we're going to be going back and looking at our Doppler data and see if we have been actually tracking the terminator, both sunrise and sunset in our data. And it'll be very interesting to see if we can see a distinct delay in the 6 receivers that we have set up. And also something that I'm sure will be observed in the WWV data. But that was a unique thing about this eclipse, is that we were actually positioned at the sunrise. So that will have a particularly unique signature in the data.
Can I can I ask a quick one of hopefully Nathaniel or someone about the emails that seem to come through from this Stephen Fell person who was pointing out difficulties that might, I can't remember how he worded it.
Was it Stephen or Larry?
Well, I guess he said Larry, but the web page goes to somebody who's the links go to someone who's whoever it is. Yeah, I don't know.
N6NC.
The thing about potential pitfalls of the thing, and I don't know exactly, that kind of seemed to fall out of the sky, but looking through his stuff, all of his problems are that he's trying to put the Raspberry Pi and an SPI connected module in the same box. He can't get them apart, and so he's sitting right in there with the magnetometer and the Raspberry Pi in the same box, and it's like noisy as it possibly can be. And he does all kinds of other things. I didn't know if that was someone that was important to try to communicate with, or where that came from, or what it was.
No, I think my understanding is that he's another ham who's been following the project, and then he saw another person work with these chips, and they found that there were some noisy problems and some pitfalls, and he wanted to make sure we were aware of them. And I think to me, from what I've seen you do and what I've seen Jules do and the other people, it seems like we have most of the problems pretty well in hand. So I'm not terribly worried about it.
Okay, but do we have any need to inform him that they're really barking at the wrong tree?
I don't think so. I thought the list did a really good job. There were a lot of people who commented back, and I thought gave some very thoughtful comments about either our engineering or what science was being done and how these measurements actually work. I thought that it was handled fairly well.
Evidently, I don't see all of the traffic then, because I didn't see hardly anything in the way of follow-up.
Oh,
so,
really?
No.
Because are you on the ham site? Are you talking about the one that was on the ham site Google group?
I don't look at that except on the rarest of occasions.
Okay, because there was on the ham site Google group, there were probably about 20 emails on that thread. So there was a lot of traffic there.
Okay, well, I should look at that more, but that's always seemed to be pretty quiescent over there, so I didn't look at it for a long time.
Yeah.
Okay, that was all.
Yeah. I think there's sometimes some confusion about what goes on what listserv. So sometimes people post about the magnetometer on the ham site list and other things on Tangerine, and it's not always clear.
Yeah, I at least only look at the Tangerines list ordinarily. Okay.
Nathaniel, while you're out, just a quick question. Did a Tangerine announcement go out this week about this Zoom tonight?
Yeah, Dev said he sent one out this afternoon.
Yeah, I hadn't seen it, but yeah.
Okay. I know he texted me that it got sent. Yes,
we did get one on the TangerineSDR list.
Yeah, I saw that too.
Yeah.
Yeah,
Well,
I
it went
think
out 527 on Hamsci, and as has been previously reported, I don't get it on the Tangerine list.
I saw it on both the Hamsci and the Tangerine list.
So this issue has been unresolved. Like for some people, it goes to both, for only one.
Yeah, so I do see it. I do see it posted. I got it through the Hamsci list, but I see it was sent to both.
Yeah, because I think, Dave, do you remember John Ackerman's post on the problem we were having on the Tapper list?
Yes.
That the listservs tend to try and make sure you only get one copy of the message.
Right.
So that it may be if you subscribe to both lists and the same message is posted to both lists, you're likely to only get one of them.
Right.
And then you'll say, oh, well, I missed the message. Well, it's the same, but so you don't really realize you missed it.
Yeah, I
Is that
know
the-
our Outlook does that.
Is that what
Outlook?
Outlook? So Outlook does it.
This was
Yeah.
a Google
So
thing.
why, if it's coming from two different lists, I wouldn't think it would flag it as the same. But yeah, I know that if I get the same message sent to different email addresses that forward to mine, my main address, I only get one.
But if you have a Google address, a Gmail address, then Google will try and say
Yeah.
you don't need both of them.
Right.
Sometimes it will, sometimes it won't. I don't know all the nuances of email filtering, but that was what we were having trouble on the TAPR board list of board members not getting email. And they would get it sometimes and they wouldn't get it other times. And then, but of course it's going out to the list. So if you copied, one person and that person was subscribed to the list and then you send it to the list also, then Gmail or Google would say, oh, well, you don't need both of these, and it would throw one away. Because you got one, you got both of them,
Yeah.
really. You got the same.
We've also had the problem that the TAPR lists get, or at least some that John has administered, get flagged as spam and go into the great bit bucket in the sky.
You've had that trouble with the Tangerine list because it's
Right.
by TAPR. So
Yeah, the last posting I have is June
I've had to help
10th.
him track that down at least once.
Yeah, last posting I have is June 10th, and I've checked the spam box and nothing's in there. So for some reason it missed me.
let's see. So for TAPR, I don't even know what mailbox it goes into anymore. I just seem to see them. And yeah, so I got on the Tangerine list, I got one from Joshi, Joshi at 2:30 p.m.
Oh, not 2:30 p.m.
That was,
Well, he's on the West Coast.
Oh, yeah.
That's
Oh,
2:30 p.m. our time. So,
okay.
and then the message before that was was yesterday on the 13th. Before that, so I think that was a private message. So there's not been much traffic on the Tangerine list. I can see. So it must be mostly happening on the Hamsci list. Anyway, is there anything, I don't want to interfere with any other discussion, but I got some info on the magnetometer Rev E, which is the new one. This is the one that TAPR's going to produce and sell. So I want to make sure we get it right.
Well, go ahead, Scotty.
So
before we end our session, I would like to talk about the issue of noise, RF noise in the magnetometer, because that was quite a bit of discussion on that. And I just wanted to touch base on that before we close tonight.
Okay. Well, can I share my screen, Nathaniel?
Yeah, it should all be enabled.
Okay. Okay, so this is what I'm proposing for the new layout, and I think it addresses all of the concerns that I had and I've collected from everyone. And the main thing is it basically removes all of the interrupt driven stuff, since I don't think anybody's ever going to use it anymore. I think Dave convinced me that it was extraneous. So I basically took the RJ45 from this corner here, the lower right, and moved it to the left and centered it. And then of course, the 40 pin connector up here, you can't do anything with, but the idea is that this J9 and the RJ45 and this header right here, this header is in parallel with the RJ45. So when you get the board, these three components will not be installed.
Okay.
And then the user gets to choose what they want to do, whether they want to solder wires in here, whether they want to put a header on with the connector, whether they want to put an RJ45 on, but the RJ45 points out this way, facilitating you to be able to put it in a small pipe and run the cable just straight up. Or you can solder your wires right to the header, the holes here. This is a through hole connector. This is through hole, this is through hole. Incidentally, since all these are through hole parts, these are the most expensive parts to install on the board by the manufacturer. So if we leave them off, it really helps reduce the cost, because you would not believe how much it costs just to solder a 40 pin connector on. Typically, it's $1 a hole, believe it or not.
Wow.
Now, if you get higher quantities, you can get that down, but still, it's got to come off the line. It's got to go into the manual assembly line. It's got to have the connector put on and someone hand solder it. And then either they may have to clean the flux off or not, depending on what kind of flux you use. But it's still got to be a separate operation. And I think what we can do with things that are not optional is that we can make them all surface mount. And so that we'll get the assembly cost is down as low as we possibly can. And I'm actually looking at these 2 strip headers here for the magnetometer subassembly. I think I can find those in SMT because those are the last things on the board that are through hole. And so if I can get rid of those, then I got everything surface mount. And it cuts
Yes, those are available.
Yeah, so I can cut the cost way down. And then for Jules, I've got the address pins here, so you can address every possible combination. So you can only put 4 magnetometers on the board because there's only 2 address pins.
Right.
So there's only 4 combinations, but this will allow you to address all 4 of them. And also it will allow you to, with the A2 line, allow you to move the remote temperature sensor off of the address of the local one so that you can actually use all 4 remote addresses at the far end for magnetometers and not have the temperature sensors get in the way.
Good. The only thing that's different about this is that it reverses in the usual pipe mount that we have where that RJ45 line runs up. It just reverses the sense of the Z-axis, but that's not a problem.
So you have it over here, right?
Yeah.
Yeah.
But that's not a problem. It's just a matter of changing the sign on the display, but it works fine. What I like about it is that the RJ45 is near the regulator, which is very good.
Right, and the other thing is that by putting it over here, you run into it when you stick it on the Raspberry Pi. If you're so inclined for test mode, there's parts over here.
Yes.
There's no parts over here, so
Right.
it comes right off the Raspberry Pi, nice and easy.
No, it's great.
Scotty?
So
go
ahead, Dave.
The only comment I would have about it is to ask whether there's any possibility of, say, moving the shield jumper just a little further back from the edge and putting a 4th mounting hole.
Yes,
very much like a 4th mounting hole.
Okay,
all possible.
easily doable. This is just representative of about where things are going to go. So if you want a 4th hole there, yeah, we can do that. I did not move this hole down to the corner. There was a reason for that, I think. Oh, that's because on the Pi 0, this is where the hole is. So if you mirror it with Pi 0,
That's all right.
Bolt it right together.
Yeah,
So
I don't
suppose we put the hole to equal a Pi 0 over here, move the shield back here.
Yeah, more or less. Yeah.
Okay.
Anywhere.
But
Actually,
I
anywhere.
tried to get this, and this actually might move up a little bit to go over the corner here because I wanted to center it so that you get the maximum overhead, the curvature of the pipe.
Right. But if we were going to use anything like the 3D printed mount pieces, having a 4th hole would add a lot of stability is my only thought.
Is that 3D printed mount, is that like a slide in or does it actually use the holes to
slide in?
Slide into does the board slide into it so it needs to grip the edges of the board?
Well, it could be either, but at the moment it's the only ones I've made. Let me turn on my camera. It just sits on them, and this is not one of your boards, but it's one of the board, and make it and my camera's pretty poor, but
we'd be grabbing it by the long edges because you want to slide it into the 1.5 inch pipe, right? Or is that not the way you would do it?
That's not really that's not what I was contemplating.
So do I have to keep stuff like this fan connector? Do I have to keep that away from this edge here?
Not as far as not.
No,
not as far as I'm concerned.
Nope.
But the holes provide a place to put a bolt to hold it together.
Yeah, I just put some nylon, a nylon 8 millimeters, or are 2.5 millimeters screws with, or bigger, I
Okay,
guess.
so
you've
this,
got bigger
so then your 3D mounts actually bolt onto the board.
Right.
So they're
Right.
positive. Okay, it's hard to see with the camera there.
I understand, and maybe some more light might help a little, but not, or make
No,
things
that made it
worse.
worse.
Yeah.
Oh, you can just see the edge of it there, Dave.
Yeah.
Oh, so you got
little tabs.
Yeah, okay.
Yeah, it's an arrangement rather like this, but it's all my stuff's black, so it but anyway, it's
So is this notch here going to be a problem for you, given the fact that this is further back from this?
not really, because I can make I can print the plastic asymmetrically. I mean, it would be nicer if it was, but
well, the reason it's like this is because there on the Raspberry Pi there's a flex cable that comes out right here.
Yeah,
which really this is going to kind of interfere with anyway. So
I don't want to make it any more difficult.
Scotty, the one advantage of having them the same on both ends is you only need one design instead of two designs for the.
That's true, because then you have clearance for the cable to come out.
There are two designs,
but there are
already.
Clearance on both ends.
Scotty, or I mean, Dave, there's already two designs because there's a hole for the connection to the RJ45 or whatever comes in one end, and there's also a hole to go out the other end, or should be, in case someone wants to daisy chain.
I'm just thinking
on the
that,
I2C bus.
that the clearance hole for the flex cable is a slot right here.
Yeah.
So I think we could actually tab this out to the same height as this one, and then it would maybe, I mean, at least the attachment points would be symmetrical, even though the parts might not be.
Yeah, I don't.
That's fine.
All I'd like to have is a hole, and it could be anywhere that I can reach.
And is this 37 millimeter? This is I can't make this any wider, otherwise it won't fit in the pipe.
Don't make it wider. No.
Yeah.
Right, because it's 37.5 millimeter nominal for the ID of the pipe, right? So I can't.
And the 23 millimeter spacing on the holes is okay with me, or anything, just as long as I know what it is. That's all I care.
Okay.
But is the pipe 37 millimeters?
ID, yes.
Well, the ID is
37.5.
Yeah. Well,
yeah. So
you
pipes
might
aren't exact. It's going to be plus or
You don't
minus.
want it exact unless you want to squish the pipe to put the board in and then let go and have it tighten up. I don't.
No, that's what I'm saying.
I
It
don't.
might
I
be a
don't know
little
how good the tolerance is on PVC pipe. It's drawn,
not.
right? So it's not very.
It's not all that tight.
It's pretty.
Tolerance.
It's
So Dave and Jules have done more of this than anybody. So we should ask them because they've been building these.
Right. Is this board then wider than the other one?
It's the same as the Rev D board. So,
okay, so I'm using the Rev E board and I find that fits nicely into 1.5 or 2.
Okay, the Rev D is what you've got actually.
Rev D. Okay, now the Rev D is the same width or is it a little narrower?
It's the exact same width. All of them are the same width. It's just the difference between the C and the D is the connector is rotated.
Yeah, it works.
But we're not gonna do that. We're gonna keep it off the end like this.
Yeah, even if I use my Plastruct channel method of mount, it still works beautifully.
Yes.
Okay, because I can't really make it I can't give you any edge to grab on the top because this connector has to be very close.
Correct.
But on the bottom, we have a little bit of slop, but then you see the problem is that the magnetometer daughter card, it's not centered and it's kind of tall. So does that have any trouble getting into the pipe being, this is the same offset as it is on the card now?
No.
North to south?
Nope, no problem.
Okay, because I moved it in the X direction to the right, but I've kept it in the Y direction, the same centering in the card.
If the centering is basically what you've got on D version, it works fine, no problem.
Okay.
Yeah, just make sure the strip connectors are equivalent height.
Right.
You
And
wouldn't want
maybe
it
I
taller.
might maybe even make them a little lower. And that would be
That
possible.
might work.
Mhm.
I got a question on this new Rev. Does it use the recommendation for changing the power and ground twisting?
You mean making the 5 volts in ground in a pair and the 5 volts in ground in another pair?
Yes.
It does not. It uses the same pin out we use right now, which is
Okay.
5 volts on one pair, ground on another pair.
That's too bad.
I mean,
That is a good recommendation,
we
but it
can
would not
switch
be
it.
compatible.
We can switch it, but yeah, it won't be compatible with the existing, with either Dave's or the Rev D boards.
Did you have a thought on that, Jules?
Well, what I did was when I tried that, I actually rewired. I didn't use a connector. I wired directly to the pins, and therefore I was able to do that 2 twisted pair ground and 5 volts on both pairs. So I made some modifications to the board to do that.
So
did you see any difference?
Well, that's the problem. I haven't had a chance to test all of my measurements for transients on the remote end that I did in about a year or so ago were done with that configuration. I have not really had a chance to compare the 2 different methods. I need to do that, and we need to really look at possible radiated EMI from the cable for those 2 situations too, and I just haven't had a chance.
Yeah, it's too bad that hadn't been spotted earlier, because that is the correct way of doing it.
It seemed like to me that the advantage you're going to get is going to be a quieter 5 volts, not so much radiated, because you're supposed to be using shielded cable anyway.
Right.
So that should take care of most of the problem.
Yes.
But then having the 5 volts on a pair is going to give you a cleaner 5 volts because it's going to get rid of the common mode.
Yes.
Right.
Anyway.
Right. That would be desirable.
Yeah.
The reason that it was put on the pairs that it was put on was to prevent a problem if you connected an existing Ethernet power over Ethernet source or load to this device. Then you could cause some bad problems. So the original wiring pair were to make sure nothing bad would happen.
Yeah, I seem to recall that was the discussion. Yeah.
Yeah. Sometimes the reasons get lost over time.
Yeah. Well, using shielded cable probably won't make a lot of difference, but I'm thinking that with unshielded cable, if you do the twists right, it may be quiet anyway.
Yeah.
Mm-hmm.
And then you've got the differential pairs, which are mated in the proper pairs. So
right.
That'll keep the noise down on those.
Yes.
Well, this might come back to what I was wanting to talk about on the noise that I discovered. First of all, to Yeoman, the noise that we're talking about is not noise in the magnetometer measurement being caused by trucks or whatever. This is noise being radiated somewhere in this system that's picked up. I noticed it on 160 meters and on 80 meters. And I found a couple of things. Number one, the Raspberry Pi chassis, normally, if you use one of the wall warts that comes with a Raspberry Pi, the Raspberry Pi ground is floating then. So what you need to do is you need to actually run a cable from the ground of the Raspberry Pi to an earth ground. That gets rid of the 1.9 megahertz spur that was, or birdie, that was being generated by the system. Now, the other thing was noise on 80 meters, pretty wideband noise. Hard to tell where it's coming from. I'm using shielded Cat5 from the magnetometer Pi hat on the Pi all the way up to the magnetometer. And you can see the noise come and go as you plug the cable in and out. So it is somehow related to the something between the Pi hat that's on the Pi and the magnetometer itself. The suggestion that's been made to me is that I need to have a linear power supply rather than the typical switching power supply that comes with a Raspberry Pi. That will have to be a custom built item because the Raspberry Pi 4B requires a 3 amp power supply, and you can't get a linear wall wart that can go up to 3 amps. So what I'll need to do is, in order to troubleshoot this, I'll need to buy a linear power supply that can do 3 amps and then wire it into the Raspberry Pi rather than using a standard Raspberry Pi wall wart. So in case anybody else is troubled by noise on 80 meters coming from the, apparently coming from the magnetometer, the thinking is right now that it's due to the power supply.
Bill, have you tried a 3B or just the 4 series?
All I've got is a 4.
Okay, my stuff runs on 3Bs, and what I have is a intermediate battery backup between the wall wart and the Pi, but that itself has a small switcher on it, so that doesn't necessarily get rid of any switching noise. But again, I'm not seeing much noise.
Well, I'm seeing it.
Okay.
I can, if you want to have an offline session, I can bring you up and show you on the Flex 6600. It's there.
Yeah, it might be interesting
to
to
go simply by plugging in the power supply to the magnetometer. So,
Do you have a frequency that you're seeing? What spurs are you seeing?
well, on 80 meters, let me see. Let me bring this up here and show you. Let me share. Scotty, can I grab this screen here for a minute?
Yeah, and I do have high power 5-volt linears available, so would be able to test that here.
Okay, can you see my screen there?
Yes.
This is on 80 meters. This here is the general noise environment. What this is the Flex 6600 hooked up to an 80 meter dipole that runs within 20 feet of the magnetometer. And the waterfall, here is where I plug in the magnetometer. So this is the noise level, which on the waterfall with the magnetometer running, and here it is with the magnetometer off. So
it's broadband noise.
It's broadband noise. It's not a spur.
Ah, well, that does probably point to the either the switcher or the processor itself.
Yeah,
because they do tend to
Well,
spread spectrum
which
noise.
processor do you mean, David?
I'm not sure, but processors, they will spread spectrum, their clocks.
Are you talking about the processor in the Raspberry Pi itself?
Right, yes.
But stop a second, David. This is when I plug and unplug the magnetometer. The Raspberry Pi processor
just the
is running the same in either case.
Right.
You're talking about,
but you're changing the antenna.
Just the magnetometer board off of the Pi?
Unplugging and plugging the RJ45 to the hat that sits on the Raspberry Pi.
Okay, but you're plugging it on the Raspberry Pi end, right?
Right, I'm plugging in the RJ45 shielded Cat6 that goes, yeah.
Right. But you're doing it on the Raspberry
You're
Pi.
doing it at the Raspberry Pi, so you're
So my
changing
point is-
the radiating antenna, basically.
The
My point is
magnetometer is out in the yard buried.
Right. So my point is that when you plug that cable in, you're not just getting the remote Raspberry Pi, you're getting 100 feet of antenna.
Right.
Of course, right, of course.
So I think what you're changing is the antenna.
What happens if you ran a dummy lead out there without a magnetometer
that's a
at the
good
end of it,
question.
or just unplugged the magnetometer and did the same experiment? What would you see?
Well, let's see. I mean, you're asking me theoretically. I have no
Well,
idea.
yeah, or is it possible
go
for
back
you
and
to
try
do
it.
that?
I'd
Right.
go out there and try it now, but it's dark outside. so-
No, but you don't want to unbury your magnetometer, so
No.
just lay another piece of cable out on the ground and plug it in on one end and see what happens.
Yeah, I mean, I
Yeah.
can unplug it from the magnetometer and see if that makes a difference.
Okay.
But hang on a second. If it's unplugged, it's not going to be pulling current.
That's
True.
true.
That doesn't
But
matter.
We're
That's
trying,
not what
we're
we're
trying to
thinking.
see if it's an antenna
Problem-
that you're getting.
Right. If the problem is still there and it's unplugged, then it's not related to current in the magnetometer is drawing. It's related to the antenna effect of the cable. If the problem goes away then we have to assume that there's something related to the current draw of the mag.
Well, no, bear in mind here, this is not really that much of a problem for me because I'm not an 80 meter DXer, but this may cause some anxiety for people who want to do this project and who are big into 80 meter DX. So
sure.
we need to have something to tell them. So the question is, where do you start? I mean, I'm willing to go through and build up a linear.
But it's probably present at WWV and any other frequencies that.
Well, and the thing is,
we
that
have of interest.
There's nothing on the magnetometer that should cause this. There's no switching regulators. It's all linear regulators. The only possible exception is whatever's inside that magnetometer part itself. I mean, it's obviously
Yeah, the magnetometer does have switching internally, but I think it's also pretty well shielded.
Yeah, I'm not suspecting that the problem is coming from the magnetometer electronic devices sitting in the ground. There's something going on with the cable that connects the.
Right.
Well, you do have 100 kilohertz I2C signals.
Right, but they only happen every minute.
True. Well,
yeah, those
no,
are bursts.
Yeah, that's true. They're bursts.
So what, Bill, is your cable shielded?
Yes, it's shielded Cat 6.
Okay.
I mean, I raise this only because I'm just trying to find interesting things that may cause anxiety for other hams that are going to try and do this.
No, that's a good point.
We can't be interfering with any of that band.
But I'm just thinking that the I2C, it runs in bursts, but the monitoring, the magneto monitoring that happens inside the 3100 part happens all the time, right?
No.
Bill?
Isn't it constantly doing measurements and averaging them?
No, only when you pull it.
Bill?
I don't think
it's
that's
running
right.
constantly because I mean, but we're polling it, what, 100 times a second or something, right?
No, I thought we were polling once a second.
But there's an averaging thing going on.
Right, so that means they're making 100 measurements per second, averaging them together, and then we read them out over I2C once a second.
Well, actually, no, it depends. You can set it up so it takes one measurement without averaging, or you could do multiple measurements averaged. If you do one measurement and it takes only about a millisecond and a half to do a single measurement without averaging.
And then what happens in between the seconds? Nothing.
It sits idle. Nothing.
So but how are we setting it? How are we programming it?
It depends upon what Dave is. You have options.
I think we're going to want to have the averaging function in there because we want the sensitivity.
So.
Yeah.
Bill, didn't you say that when you did ground through the audio plug on the Pi, this effect disappeared?
Not disappeared entirely.
Or
here's the thing.
improved.
When you ground the chassis of the Raspberry Pi by running a line to an earth ground, it completely eliminates the problem under 160 meters, and it cuts it about in half on 80 meters. So it's not completely gone, but it's cut about in half.
Okay.
So
I don't know how that bears.
So it'd be interesting to see if this is being radiated by your Cat 6 and on the shield, because the shield is connected to the Raspberry Pi ground. So,
right.
Yeah.
So one thing would be illustrative is leave it plugged in and just take the jumper, the ground jumper, off of the Raspberry Pi mounted board that disconnects your shield from the Raspberry Pi ground, and see if that makes any change, does any change at all.
Say that again, Scotty.
If you hook everything up like it is normally, but pull the jumper off on the magnetometer board that is on the Raspberry Pi that has no RM3100 on it, but it has a jumper to connect the shield to the Raspberry Pi ground. So pull that jumper off, and that will disconnect the shield of your cable from the Raspberry Pi ground, and then you can see if it makes any difference in your measurement here.
Well, there's a couple different jumpers on this board, the version I have. Which jumper are we talking about?
Hold on a second. I will tell it unto you. You've got Rev D. So it is jumper 4, JMP4. It should be right next to the cable, the RJ45.
Yeah, I can try that. Yeah. I can try that, but
You could even do that when it's dark.
yeah. Yeah, I mean, I can't get good measurements now because there's so much lightning in the area that the noise level on 80 meters really doesn't let you look at anything. I just looked at that right now to see if I could do anything on 80 meters, and this the amount of garbage on the air due to lightning is
So
precludes.
this graph that you're showing, what time of day was it made?
This was, I think, in it's the middle of the day, like in the afternoon.
Okay, so you should be getting very few skywave signals at all then during this time. So that's good. That's what you want to see is the local interference.
Right.
Yeah, so I'm sorry, I didn't want to monopolize the conversation with this, but since there was so much traffic back and forth on the mailing list, I thought I would raise it. I will try with the Jumper 4, and I'm also going to try, I will get a linear power supply that can power this device and see if that will clear this.
Also do try unplugging the cable at the magnetometer end when it's convenient, and try that to just look at it as an antenna alone.
Right.
Yeah, because it's hard for me to believe that the magnetometer is actually generating this level of interference.
No, I'm sure it's not. I'm sure it has to do with the cable, but you got to have a cable going out there somehow.
Right.
So
would this
we got
be
to figure
something?
out how to quiet the cable down. I guess I'm saying.
Would this be something we could do with toroidal cores, or is that only
Toroid
really
beads, well, big, clamp-ons.
I've got clamp-ons on there already. They made no difference at all.
Okay, which material? 31 or 43 material? What material? do
It
you have?
doesn't say on the ferrite what it is.
Yeah, I actually use some different numbers for lower frequencies myself.
Normally that's
there are a lot of
73,
different
77,
possibilities.
yeah.
And also we use larger toroids and wrap the cable around through it several times.
One of the difficulties here is that cable is probably not a low impedance. If it's a fairly high impedance, the ferrite's not going to do too much.
Yeah,
It has nothing to do with the impedance of the cable.
True.
Well,
it's really
you're looking to choke the currents off of the outside shield.
It has to do with the impedance of the cable as a common mode antenna. And if that's a high,
in that respect, yes. Yeah.
if it's a high common mode impedance antenna, then there's not much current flowing, and the ferrite's not going to do too much.
Yeah, you're going to need a large clamp with about 4 to 7 turns through it to get at those frequencies to get an impedance up around 5,000 ohms. If you look at K9YC's website, that's a beautiful reference for that.
All right. I don't mean to take up the whole evening with this.
If you put snap-on cores, you're going to need a lot, just as antenna balun uses a ton of cores.
Don't worry, Bill, because we have to get this fixed, so it's important.
Yeah.
So I'll play around with the other.
By the way, there are actual common mode chokes that are available for Ethernet. Toroid core with multiple twisted pairs going through it. Very small, compact, made exactly for this purpose.
Yeah,
you may end up using something like that.
Yeah, they
I will make a note to look up stuff like that.
Where do you look for something like that?
If it turns out to be power supply related, we're going to have a hard discussion with each person that want to put one of these systems in. Tell them, okay, you can't buy one of those power supplies from Raspberry that can do 3 amps because it's switching. Rather, what you've got to do is you got to buy a linear 3 amp power supply and wire it correctly. And by the way, you better not hook it up wrong because you'll burn up the Raspberry Pi. So,
well, you don't necessarily need a linear; you just have to have a known good switcher. There are such. We just have to have a list of recommended supplies.
Yeah, if anybody can recommend one, I'll be willing to try it. Let me know what it is, where to get it. So
my experience is TDKs are pretty damn quiet, but
write that down.
I use a lot of TDK stuff.
just Scott, before we go, I'd want to have just check, do we have concurrence on the wiring of the RJ plug regarding ground and 5 volts?
Well, if we're going to want to keep compatibility with existing systems and not blow up power over Ethernet, I guess we live with it the way it is.
The issue with Ethernet is more important, I think, because you can buy these in pairs, never mix them. That won't be too hard. But if you plug it into Ethernet and burn something up, that's not really good.
No, that's true.
Somebody's going to get upset.
Yeah.
I think we can make it work. You know, mine are working well out in the field. I've got 400 feet of line going out to a dual mag setup, and that's working fine. I'm looking at transients at the end of it, and I've got some filtering on the 5 volt lines at the end of that, and there's no problem.
Yeah, and shielded Ethernet is not hard to get these days.
No.
There was a time that would have been esoteric.
Yeah, and by taking out the interrupt line, we actually added additional 5 volt line to the, there's only one wire being used in these for 5 volts, but there'll be 2 wires now because we took out the interrupt. I was using 1 line for interrupt. And it's still, if you do the calculations, you just, with the LDOs that we picked, you can still get over 300 feet of line, even with 1 5 volt and 2 grounds. Now with 2 5 volts and 2 grounds, it's just going to lower the impedance of the 5 volt feed. So it's just going to be better. So anyway, so it looks like we can make the tab here work. So we can make the board, we can put tabs on either end. So that means the holes will be symmetrical. And we can move them down to the corners. So
they don't have to be right at the corners, but you know,
just the normal, like the 3.5 millimeters in from the corners, or maybe a little bit higher. I think it doesn't really matter how far it is, like you said. So, but it'd be good to keep it symmetrical, because they do 3.5 millimeters from the short edges and 4 millimeters from the long edges. So just copy that, and make it the same. So you will have to have the hole on one end, but other than that, the mounting things will be the same.
And I like that set of jumpers right behind the right behind the RJ45, because it gives us a place to.
Yeah. So let me try this here again. Hold on. Okay, so you put the tab out. Like that. So the board outline then cuts in here, cuts back out here, and these line up. And I'll get the dimensions right. But that means we could put the hole like down here and move this hole down so it's 4 millimeters off the bottom. And so they'll be symmetrical, except for the hole required. Whoops, not like that. I love OrCAD for drawing. This is not the proper use for this tool. But hey, you use what you have. So anyway, that kind of lays it out. These will be, I know this cutout has to be 17 millimeters wide. So that puts it at 29. So we'll have 8 millimeters here, which will be enough for the hole. 8 millimeters. To there. Boy, I'm having trouble tonight. So that should do it for making things symmetrical. And then this will be, you notice it's 4 millimeter from the top edge. We'll make it 4 from the bottom and 3.5 in from the edges, outside edges. So that should work for you, right, Dave?
Sure.
And we'll keep the width of the overall width exactly the same. And make sure that the RM3100 doesn't end up being any higher off the board than it is now.
Yeah.
So on this connector here, when if this was mounted, which part hits the pipe? Is it the pins or the header, the plastic part?
The plastic part.
Yeah, plastic.
Really? Okay, because it's so close to the edge.
Mm-hmm. Right.
Yeah.
Okay, because I would have thought you'd have trouble with this edge over here too, on the bottom.
Not so much. And also, what I've been doing on these things is looked at from an elevation view, which you can't do there. I've been making these plastic end pieces asymmetrical, lower, so I don't know if I can explain, but.
Oh, so you don't mount it centered in the pipe then?
I do mount it centered, pretty well centered on the magnetometer, but I lowered a bit on the width. That's one reason I'm not, it doesn't have to be exactly 37 millimeters wide. If it can drop down just a little bit, then everything fits nicely. And the magnetometer is a little bit more centered in one dimension, in the vertical dimension.
So if you put this edge against the pipe inside, then you get a little bit of gap here, which pushes that further away from the edge.
No, that's not what I'm saying. I'm saying that in an elevation view, what you've got,
right.
If you look
90 degrees and look at the side.
Yeah, it's not quite, I can lower the tabs so they're below the center. In fact, I need to some extent if there's an RJ45 going to be there, because it sticks up way up above the board. And in order to have something close to centered on these end pieces, I have to make it asymmetric.
But we're going to be moving the RJ45 to the center line, so that's going to help you.
Yeah, that helps me a lot. That center line in the
along here, this center line.
Yeah.
You still have the elevation to contend with.
It's the elevation.
Yeah. Right.
Scotty doesn't think a lot about elevation because except when parts start banging against the case.
I let my CAD guy give me a 3D model.
Yeah. Well, it's just that if it's a little bit less than 37 millimeters wide, well,
we could shave a millimeter off if that would help. I mean,
it's not going to hurt anything. Is what I'm saying. Even 2, but I don't know if that interferes with Jules's
limitation is, that would be the question, because the limitation for me is the width of this board right here.
Right, which is
I rely on this area in here for routing.
Right.
This area for routing between this, so I can't move it up any. I can't move J9 up any. I might shave a millimeter off down here because we've taken a lot of parts off. But also, since we put the magnetometer, the raw magnetometer parts in the middle, I really don't want to run a bunch of routes through the middle.
I can understand.
I would not take off more than a millimeter if you take off anything at all.
Okay.
Yeah, you don't have to. I'm just saying.
Yeah.
I just want to make sure it's going to fit for you, Dave. If it's not going to fit, then you got trouble.
Yeah. Well, no one's obliged to do it this way, and I can fiddle with this. I mean, Jules has a good approach that if this isn't perfect, but I'm just saying that what I've done with my boards, which were probably a little less wide than that. Let me see. No, they're mine are 34.
Okay, but
mine are
Dave,
30.
Based on what you've done and what I've done, if you drop your tabs just a bit, it'll work fine. No sweat.
Yeah. Yeah, I certainly dropped the tabs the thickness of the board,
Yeah.
if nothing else, you know.
And that just moves it down in the pipe a little bit below center, right?
Yeah.
Right. Yeah, well, it actually, if I just move it that much, it makes it at center. And if I go deeper than that, yeah. It's all experimental. In fact, there doesn't even have to be a complete circular, you know, a lot of things.
Yeah.
And the symmetry, if the magnetometer is offset from the center line, that's okay, as long as the center line of the magnetometer board is parallel to the center line of the pipe. It doesn't matter whether it's shifted a bit relative to that. It's basically you're looking at the axial alignment, and you don't worry about anything else.
Okay, I did worry a little bit about that, but it's good to have your thoughts.
Will this work in the way you're setting it up, Jules?
Yeah.
Okay.
Sure.
Okay, well, we'll see if I can shave a millimeter off, and I'll leave it at that. And
yeah, as long as that doesn't mess with Jules's.
Nope, that won't do anything to mine at all. Nope.
And then we'll put the RJ45 more or less in the middle here.
Mm-hmm.
It'll probably be a little offset. And what I'll do is I'll just move this edge up, because this 17 millimeters here starts at 12 and goes down 17. So as long as I stay out of that area, then we'll be okay for the Pi. And in fact, yeah, because you want to be able to plug this onto a Raspberry Pi. I mean, one end has to go on the Raspberry Pi, right? So you got to be careful and not, but it is a flex cable. It is below us, and it will bend and come out this way.
Mm-hmm.
So, I believe it's either the camera interface or the LCD interface. I don't remember which one it is, because there's another one down here at the bottom, which we actually don't interfere with because our board's too narrow. There's another slot, horizontal slot down here that's a keep out, but the board's too narrow to interfere with that, so we don't bother. We don't have to do anything down here. If I make it even narrower, then all the better. Okay, I think that covers everything. It gives you all your address jumpers, all the possible addresses. We have the shield jumper. We have the write enable for the prom, which is okay. And then the other thing, I'm going to take this out. This is the magnetometer disabled. This was actually not, the pin doesn't do what I thought it did, so that's going away. The idea was that you could disable the magnetometer, but that's stupid, because if you want to disable the magnetometer, just unplug it. I mean,
don't put it in there.
Don't plug it in. However, that was for the case when you had magnetometer components mounted on the board, because I was leaving that option open to be able to do that rather than have a header.
Yeah.
Because part of the problem is that these headers come from P&I without the male pins on them, which means that somebody's got to solder the male pins on. Well, if you're going to do soldering anyway for this, you can solder the male pins on. But I soldered 50 sets of them on the boards that everybody got. So it took me less than an hour to do that. So it's really not hard.
And they charge you $20 to solder them on for you or something like that.
Yeah, ridiculous amount. $40, I think. It's $64, isn't it, for the pins on it?
Yeah, you're right.
$20 for the other one.
I'm in the wrong business.
Yeah, really. I soldered them on for much less than that. So I think I'll charge double this time. That's the same amount. In case you're math challenged.
I would say I'm an amateur solderer. I do it because it's fun.
But you can solder 10th inch stuff easy, right? Anybody can do that, right?
Indeed.
So
no.
So actually, probably Jules, what I'll do is I'll leave this address header off also and make it through hole, because actually through hole headers are way cheaper than surface mount headers. I could buy a 6-pin header like this probably for 6 cents. But if I want a bent pin through hole one, it's like 50 cents or more. So plus that I have to pay to, so it's a trade-off. I have to pay to have it soldered in, or I have to pay to buy it, one or the other. So anyway, so I'd make it through hole and I'd leave it off, and we'll just include it in the kit. And then if you want to use it, solder it in. If you don't want to use it, don't. And then we'll probably have to have some kind of kit that has everything soldered in for those who absolutely don't even own a soldering iron. There are a few of those, right? Who want to play but don't have an ability to solder. So Jules, on your setup, you actually solder the cable into the header, right? Or into the holes of the RJ45. You're muted.
The last one I made for Hyman, I actually used the RJ45 connector. The one I did before that, I soldered the pins to, or soldered the wires directly into the holes. So I've done both.
Okay. So when you use the RJ45, did you just bought a pigtail that had a male to female with a bulkhead on one end?
Yeah, basically.
Okay. And those, you can get those, right, with that are.
Now, what I'm actually doing is for the waterproof connector, use a female to female in a waterproof bulkhead mount, and then internally in the pipe, I'll either use male to male jumper, or I'll use a male with just the open wires at the other end and solder those in.
Okay.
I've bought patch cables and just cut them in half.
Yeah, right. Basically, I'll take a patch cable and cut it.
I get two.
Right.
The price
two
of
for
one.
one. Exactly.
But you could probably a 6-inch or a 1-foot patch cable. You could just use the RJ45 and just plug it in, right?
Yeah. Right.
So okay.
I mean, there's several ways to proverbially skin the cat here. Whatever works for you is,
Yeah.
you know,
I'm just trying to figure out in the Tapper store when we put these up for sale, what variants do we have to offer?
Right.
Because ideally, I'd like to offer boards, everything assembled except for the 3 parts: the header, the 2 headers, the RJ45, and the J9, 4 parts.
Mm-hmm.
And they're all through hole. So just give the people the parts and give the people the board, and they can decide what they want to, how they want to solder them in, whether they want to use cable in the hole, whether they want to use an RJ45, whether they want to have extra addresses or not. But then anyone who uses the Raspberry Pi, I mean, everybody's going to have one on the Raspberry Pi end, right?
Right.
That's the inside end. So somebody's going to have to solder a J9 on,
Yep.
Otherwise it's not going to plug on.
Right.
And you're probably going to want an RJ45 on that one. And then the 2 headers become just irrelevant. So ideally, we're going to have 2 variants, a completely assembled one and a one with the 4 loose parts. And then you could either buy one of each, or you can buy both unassembled, whichever way you want.
That sounds reasonable.
The only problem is that the assembled one's going to cost more to make because I got to pay somebody to solder those 4 connectors in.
Mm-hmm.
And that's because we're talking about actually having it being made here in Tempe, because my CM has a new pick and place and a reflow machine, but he's got USA rates. So for labor, so when you tell him manual labor, price goes way up. So I think we can actually be close enough to be competitive when you compare it to all the shipping you got to go through and all that to have it made overseas. I think we can make the surface mount part here. So it may be, maybe we'll get some local Boy Scouts to solder the parts on for free for soldering practice on the ones that we want to sell with parts on them.
Do we want to sell a mounting kit with these things?
That would be nice. I mean, like a pipe and end caps and the dual female and the, whatever you come up with. Yeah.
Yeah.
So how much is it going to cost me to buy 500 3D printed sets of brackets from you, Dave? You can do that in a couple months, right?
Yeah, a couple of months. It's not as quick and easy as it might seem.
So given the fact that you've designed the part and you 3D printed it and you've tested it and it works, where would you go to get 500 made? Is that something that's possible?
Well, 500, I don't know. I've never talked to any of these people, but there's an outfit, say in Minneapolis, that'll take the CAD and probably somewhere in China, that will take the the CAD and perhaps a 3D printed part or two, and will convert it to an injection molding thing, which they can crank them out by the billion, you know.
But then how much does the injection mold cost?
The setup cost is going to be high.
It's going to be high. Yeah. So I don't know. I think my thought was to perhaps make, you know, with very carefully and thoughtfully, after some experience with people fooling with these, you know, provide some of them to some folks and see how it goes. And then if it seems really necessary to make them available to people, then make some cautiously available, but also to say, provide the design to anyone who wants it through the usual kind of thingiverse or something, and say, here, print your own, because some people do. I doubt as many. I think people, you know, it's hard to say. And but some people might prefer to do it a different way, Jules's way.
I think though you're going to get more people who can solder than have 3D printers.
Yeah, but you probably have people that have local maker spaces that might be able to do it there.
Yeah. It's just that the guy who wants to put his Visa card down and get the whole kit is not going to be able to do that.
Right.
Yeah. Well, that's something, you know, I can do a little more research on you know, there may be people, you know, a lot of folks have, there's outfits that have rooms full of standard 3D printers that can just feed the jobs in parallel, and you make 8 or 10 at once. Pretty soon you can make quite a few.
At Case Western, they have a lab like that that's free. You can walk in, you can 3D use their printers.
I was just going to mention that this could be done by Case Western Reserve. They have so many printers. It's unbelievable.
Do they have a you know, like a thing where they can use something that just feeds them out as jobs to the whole room at once, and, you know, has, or even 10, you know, like 10 printers that we're doing 10 per batch, and they take an hour to print, but you'd get 100 at a time.
So you'd fire it up at midnight and then leave and come back in the morning, and there'd be 100 of them there.
Yeah.
Well, you have to take, each one has to be taken off the printer when it's done. But we could ask Christina or John Gibbons, and they could give us some feedback on whether that be an option.
Yeah.
It's just that when you get to the quantity of 500, you know, especially so Dave, let me make a suggestion here and tell me if I'm full of it. But couldn't you make a single part that has a hole in it and use it on both ends?
Yeah.
So then if we work this right, we can make it so that you need 2 of the same part, which now I want 1,000 of them. Now maybe make it more economical to buy in China.
Maybe.
I don't know how much the mold costs, but
I just did a Google search. There's a link I put in the chat that says protolabs.com production injection molding with no minimum order quantity. I don't know if that helps.
See, I think that may be the Minneapolis place I'm thinking of.
But you know, even if it was $2 a piece, that's
Minneapolis.
That's even at a couple dollars, that will be very lucrative for someone to mold them, but not very much money for us to put them in the kit.
You know, you never know till you ask.
Yeah.
These would be very simple things to make, but they would be very useful to.
And I'm really up for having a single part number kit the tapper could sell that would say, here you go. Here's the one that you guys have designed. Here's the pipe cut to length. Here's the caps. Here's the connectors. Here's the cable. Here's the 2 brackets, and just a sheet of instructions on how to put it together.
I'll get in touch with Proto Labs, at least as far as, you know, just to get a feel for what a domestic thing.
Yeah.
You
And
know,
I
if
think,
you're not
I think the 500 to 1,000 quantity is a good one to ask about.
sure. Okay, that gives me something to ask. That's the thing. I hate to talk to these people and they ask me that and I don't know what to say, you know. I like more than 10.
And I mean, if we have to buy 10,000, but they're 10 cents a piece, then we can do that, and then we'd have a lifetime supply.
Right. Something like that. But I want to get my hands on one of the final boards before and test
Well,
everything
and
before.
I just had a few minutes that I wanted to, so I don't forget completely on all the things we talked about. I wanted to put this down so that I could run it by you guys and see if this I'm close to what we need. It sounds like a few tweaks and we might be there.
Looking good to me.
Yep, here too.
Okay, because I mean, like Nathaniel says, we're pretty much out of prototypes. So, and the whole idea of building the prototype was to build real ones that we could sell.
Right.
So lots of people can play.
Yep. I think there's a whole set of lessons we can learn from that part of the exercise too. I mean, we're still learning a lot from individuals, testing them in their one at a time in different circumstances, but it's a whole nother deal when a whole bunch of people start.
Yeah, our rule of thumb is when you build one of something, you're going to find certain problems. When you build 10, you're going to find the 10% problems. When you build 100, you're going to find the 1% problems, and as it goes on up.
Yep.
So I'm really interested, Bill, in your results of your experiments when you see what happens. Because I really, if we have to do something, now would be a good time to do it. And maybe we try to prototype it on an existing board. If we come up with, if there's something we need to do to change the board, try it and make sure we get it right before we commit it to another design. Because I really don't want to do another prototype. I already begged Tapper for the money to do the layout and prototyping once, and actually Nathaniel paid for, I think we paid for the NRE, and Nathaniel, you paid for all the boards with one of your grants.
Yeah.
But by the way, Scotty, I did get the other magnetometer that you sent a few days ago.
In 3 days?
The first one you sent took me 3 weeks before I got it. And this one I have in hand now today.
They figured out where you live.
I know.
No, I got 300 meters of PEX tubing, I think it is, from China in about 5 days or less.
Oh, wow.
I don't know. I don't know how they do that.
Yeah, I don't know.
Right, gentlemen, I have to say 73. I had to go QRT, but we'll be in touch.
Okay, thanks, Bill.
Okay, thanks, Bill.
Yeah, I heard that off the West Coast, there is a lineup of ships that are clogging up the port, and they're claiming they aren't even going to get the backlog cleared until August. Till August.
Can't they use helicopters or something?
I don't know what the story is. It's like, and last I heard now, let's see, plastic is in short supply. Pork is now in short supply. Chicken is in short supply. It's like,
my understanding is the primary problem is the containers are in short
they
supply.
can't get containers. That's right. They said in South America, they have coffee beans surplus. They can't get containers to ship it here. So I don't know if beans go bad or not, but
You know, the problem in the container industry is this goes back about 15 years when we were working with security and containers. And most of the container guys said, well, you know, we got about 1 million out there, but we have no idea where half of them are at this time, because they're typically brought to a site, they get unloaded, and then when there's a need for a container again, somebody goes out and picks it up and brings it to the next site. But but that's a lot of paperwork, and the bookkeeping is lousy on that stuff. So there's probably a lot of containers available, but nobody knows where they are exactly.
Well, I know I bought a container to store stuff in for my upcoming move here that's going to happen probably next year. I bought it from a friend of mine from the Explorer Post. He was moving to Kentucky and he didn't need it anymore, so he sold it to me. And so I had to call up a container outfit to get him to move it, right?
Right.
Well, I asked because I wanted to buy another one because I needed 2 of them. So I asked him, well, do you have any containers available? And he says a container that used to cost $1,900 a year ago is now $5,000. And he says he recommends buying, and he calls this a one-trip container. So what you do basically is you buy the container, they build it overseas, they fill it up with goods, they ship it, they unload the goods, and they give you the container, and you get a one-use container. So you basically get a brand new one, and it's $6,000 for that. So he says it's a brand new paint job. It's not all beat up. Everything is good on it, but it's only $1,000 more than buying a used one. So it looks like I'm not going to get a second one because that's a lot of money for. I can pay for a mini storage for a long time for $6,000.
Yeah.
So I wonder if I noticed that I did a Google view of the container company. And even what are those, maybe a year old, those photos, or within the past year? The satellite view I did of the container company. And I look and I see like 3 containers on their property. And this is a container company that sells them and moves them and fixes them up. And they got 3 on their property. So, because I guess they are in short supply. It's interesting, though, that you say that there's plenty around, but they just don't know where they are. That's amazing considering how much they cost.
Yeah, it is. And, some of them, larger ones too, may be delivered to a large retail chain somewhere, and it may sit there for 2 months before it's fully unloaded.
Wow.
So there's that problem as well.
So they almost treat it like a pallet.
Yeah.
Okay, well, I just am building my house at the wrong time.
Yes.
Yeah, when somebody tells me, oh yeah, lumber's up 400%.
Well, you have to do what we do at Stellafane. We are a tree farm and we make our own lumber.
All right, I'll be right over.
Kind of slow though.
Yeah, so what do you need 2x4s? So you plant a tree and then you wait 20 years and then you harvest it?
No, we've got a lot of planted trees.
Okay.
We have there's no dearth of trees that need to come down. So.
Well, I find it interesting. I read an
Yeah,
article.
we're the Amateur Telescope Convention once a year, but the rest of the year we are classified as a tree farm, and we make use of that. And so all the stuff that we build on site, we take down our trees that we're going to take down anyway to clear things, and then we've got a portable sawmill and make our own wood.
Well, I was reading about wood product plant in Maine. Apparently, Maine is the most highly forested state in the United States. That's what they say anyway. So this plant now, they say they're working full shift, 100% capacity, and they've got electronic machines that will actually take a tree, it will measure it, decide what the best cutting to do is to get the most lumber out of it, and it will automatically cut the thing and send it over to the kiln to be dried.
Yep.
And so they said that the problem was that they had now that the pulp industry has kind of gone QRT because paper usage is way down, they didn't have any place to send all their chips, all of the pieces they cut off. So what they did is they spent a whole bunch of money and they built a power plant, and now they burn the chips and they supply power to about 300 homes that are around the area of the plant. But
yeah, we have wood chip plants for power here in New Hampshire.
They say the problem is in Pennsylvania, there was one that burned down and they decided that it wasn't worth the money to rebuild it. So now the pulp plants, the wood plants in Pennsylvania don't have any place to send their chips.
Right.
So they got mounds and mounds of these chips. What are they?
Now, the interesting thing, you say that Maine is the most forested. Well, that's new because, what's that?
That's what the article said.
Well, it could be at this point, but that's actually new because 100 years ago, this whole part of the country was nude. Great for astronomers.
So it's all secondary growth,
but it was all cut down for shipbuilding, sent over to England at one time, and fairly recently it only started growing back up. But where they really have a problem, where pine trees are a weed, is down in the South Carolina and such. They'll pay you to cut trees.
Really?
Yeah.
So why isn't somebody doing it?
Because there's so many of them.
That's why you see all those trains heading west.
Yeah.
But
yeah, though
ask
most
Dave
of our
Larson
lumber
about
is
it.
coming from Canada.
Oh, there's
Go
no
figure.
Till they get mad at us because we slap tariffs on them.
Right.
I'm gonna say
they got
73,
tipped
guys.
Yeah, I think it's that time.
Thank
All right,
you.
well, thank you guys for the input.
73 all.
I'll,
Okay.
Thanks.
come up
Gotta
with
head
some,
out.
some finals and I'll run those by you again.
Good enough.
That
Thanks,
sounds
Scott.
really good. Thank
Very
you.
good.
Okay.
Thank you very
Thanks.
much. See you next week.
Good night.
See you.